Hello children, welcome back to Insight Engine Academy. We have discussed rules to draw the ray diagram for concave mirror in the last video. Okay, so now we are going to talk about rules to draw the ray diagram for convex mirror. Okay, see, we are going to draw the ray diagrams for convex mirror. What is the purpose? The purpose of drawing the ray diagrams is understanding the characteristics of image. So to understand the characteristics of image formed by the convex mirror and concave mirror, such as spherical mirrors, such as concave and convex mirror, so we use ray diagrams. Okay, see, so this is convex mirror. We know that convex mirror and concave mirror has curved surfaces. This is inward surface, this is outward surface. When inward surface is silvered, the outward surface act like a mirror. Okay, the surface of the mirror which is act like a mirror bent outwards, that is called convex mirror. Okay, see, as this mirror has the curvature towards right side, see which side it is bent towards right side. So it's like this convex mirror has the curvature towards our right hand side. Okay, curvature in the sense, in Telugu we call it vanka. Okay, so it is bent towards right side. So usually where do we have the center? Towards right side. This is the real center. Center of the sphere is called center of the curvature. Okay. Now when a parallel beam is going to incident on this, okay, after reflection what happened? See, since this mirror has the curvature this way, and the surface of reflecting surface is bent outside, after incident on the surface of the convex mirror, this ray deviates this path, deviates through this way. It never goes towards principal axis. So this ray also goes this way, and this is the ray which is incident on it after reflection. Since this has the outward surface as the reflecting surface, after reflection it moves away from the principal axis, not towards principal axis. This goes away from the principal axis, not towards principal axis. Then what happened? All the rays diverge after reflection. That is why this mirror is also called a diverging mirror. The ray which is incident exactly on the pole after reflection traces the same path, because this is passing through the center of the curvature. Okay, so as the rays are diverging after reflection, they never meet at one point. Do they meet at one point? No. So there is no converging phenomenon will happen. So what happened? Only diverging phenomenon. Then how do we get the image? For understanding that formation of image, what do? We have to extend these rays towards back. That means behind the mirror. So when you extend these rays behind the mirror this way, all the light rays, okay, this is a reflector ray, I am just extending this. So this is a reflector ray, I am extending this. So this is a reflector ray, okay, I am extending this. Then all the light rays meet at one point. This is called principal focus or focal point. This is a real focus, and this is the real center of the curvature of the convex mirror. But these real focus and real center of the curvature are lie behind the mirror. Where are they? They lie behind the mirror. But generally, where do we place the object? We place the object before the mirror. That means we have to place here on the principal axis here. But actual focus and actual center of the curvature is behind the mirror. Then how do you place the object? With the same distance, we have to imagine another focus, that is virtual focus, F dash. With the same distance from the center of the curvature, we have to imagine another center of the curvature. This is virtual center of the curvature. This is virtual center of the curvature. This is virtual focus. This is real focus, this is real center of the curvature. Okay? So this is convex mirror. Now we are going to draw the ray diagrams, rules to draw the ray diagram for convex mirror. This is real focus, this is real center of the curvature, This is virtual focus and this is virtual center of the curvature. Okay, F dash and C dash. We can place the object anywhere on the principal axis. For example, let me place the object beyond the center of the curvature. Somewhere else we can place anywhere. Okay, so from this object, infinite light rays are going to incident on this mirror. Infinite light rays are going to incident. Among all those light rays, okay, we will consider only a ray passes parallel to the principal axis in this case. Okay, so this is our rule number 1. First we are learning rules to draw the ray diagram, then after we draw the ray diagram. This is rule number 1. What happened when a ray incident parallel to the principal axis and incident on the mirror? What happens after reflection? See, first we will draw the normal. So normal is usually passes through the center of the curvature, right? This is the normal. So this is incident ray. This is normal. The angle between incident and normal is called what? Angle of incidence. Light obey the laws of reflection. Whenever the ray which reflects, it makes equal angle to the normal. Okay? Normal and incident ray make some angle, that is angle of incidence. During the reflection, that reflector ray also make the equal angle of incidence. Then this ray makes same equal angle and reflects this way. This is the reflector ray. But very important and interesting situation is when you extend this reflector ray behind the mirror backside, this ray seems to be passes through focus. See, this is. Okay, then how do we write this rule? This rule we write as a ray passes parallel to the principal axis after reflection seems to be diverge from the focus. It's where it is coming from. It appears generally it is coming, seems to be coming from focus. It seems to be coming from focus, diverging from focus. Okay, that is why it is called this way. A ray passes parallel to the principal axis. A ray passes parallel to the principal axis of convex mirror after reflection. After reflection, it seems to be diverge from the focus. Seems to be diverge from the focus. So this is rule number 1. Any ray incident parallel to the principal axis compulsory after reflection seems to be diverge from the focus. Then only this angle I and angle R both becomes equal. Angle I is equal to angle R. Okay. Next, rule number 2. See, this is real focus and this is real center of the curvature, but we are going to draw the virtual focus and virtual center of the curvature. We can place the object anywhere on the principal axis. Here this is my object, right? So a ray from this tip of the object, infinite light rays are going to incident on the mirror. Infinite light rays are going to. Among those, previously we have taken ray passes parallel to the principal axis. Now we are taking ray seems to be passes through focus. What happened if there is no mirror? This ray compulsory passes through focus, but mirror doesn't allow this light ray to pass through focus. Then what happened after reflection? It passes parallel to the principal axis. Why? Because when we draw the normal passes through center of the curvature, right? When we draw the normal, here angle of incidence and angle of reflection both becomes equal. Okay? Light compulsory obey this law during the reflection. That is why to make these both angles equal, this ray compulsory passes parallel after reflection, which is incident and seems to be passes through focus. Okay? Right. This is rule number 2. This rule number 2 is exactly opposite scenario of the rule number 1. Just imagine we placed one mirror perpendicular to this reflector ray. Then what happened? This reflector ray traces the same path and incident on the mirror. After reflection, passes parallel to the principal axis. Actually, it seems to be passes through focus. That is only we have drawn here. Ray seems to be passes through focus. After reflection, passes parallel to the principal axis. These both are exactly opposite scenario. Next, a ray seems to be passes through focus, or it is also called a focal point of a convex mirror. After reflection, it passes parallel to the principal axis. Okay, see, a ray seems to be passes through focus. After reflection, passes parallel to the principal axis. This is rule number 2. So let me explain rule number 3. Since inward surface is silvered, outward surface act like a mirror. Okay, now we are going to learn rule 3 to draw the ray diagrams for convex mirror. This is pole, this is real focus, and this is real center of the curvature. This is virtual focus and a virtual center of the curvature. Okay, so object is placed here. Okay, now from this tip of the object, infinite light rays are going to incident on the mirror this way. Infinite. But among those, previously we have taken one is parallel and one is passes through focus. Now I am taking passes through center of the curvature. A ray seems to be passes through center of the curvature. A ray seems to be passes through center of the curvature. After reflection, traces the same path. Why? Any ray passes through the center of the curvature. When you draw the tangent, it makes 90 degrees. Okay? So the ray passing through the center of the curvature, which is meeting at the point of the mirror, when we draw the tangent at that point, the tangent is perpendicular to this. So that means it is hitting perpendicular to the mirror. Then after reflection, what happened? Traces the same path. Okay? So let me write. A ray seems to be passes through center of the curvature, traces the same path. After reflection. Okay, so these are the 3 rules we use to draw the ray diagrams for the concave mirror. So after little while we are going to draw the ray diagrams. Meanwhile, please write down these ray diagrams in your notes. Till now we have discussed rules to draw the ray diagram for convex mirror. Now we are going to draw the ray diagram for convex mirror. See, this is the real focus and real center of the curvature of the convex mirror. Why? Because this curvature, the curvature of this convex mirror is towards right side. So when we complete the sphere, we get the center here. That is why the center, the real center is towards behind the mirror. When a parallel beam is incident on the convex mirror, since it is a diverging mirror, after reflection what happened? The rays move away from the principal axis. So when we extend them, we get the focus, original focus, actual focus behind the mirror. So actual focus, the real focus and real center of the curvature is behind the mirror. But generally, where do we place the object? We place the object before the mirror. Then what do? As we have discussed earlier, we just imagine virtual focus and virtual center of the curvature from the same distance of these both. Now, where the object should be placed beyond C dash, virtual center of the curvature. This is my object. Object is placed here. What is rule number 1? A ray passes parallel to the principal axis. After reflection, seems to be diverge from the focus. This is rule number 1. What is rule number 2? A ray seems to be passes through focus. A ray seems to be passes through focus. After reflection, passes parallel to the principal axis. So when we extend these both, this is the reflector ray and this is also reflector ray. What happened after reflection? Are they converging? Are they diverging? This is going this way, this is going this way. They deviate. They are deviating each other. They are not going to meet. They are deviating. So there is no chance of meeting and formation of image before the mirror. Then what do? We have to extend them backside. After extrapolating, these rays converge here. Here the image is formed. Okay? This is the image of this object. Okay? Now, what is the position of this image? Position. Object is placed beyond C, then image is formed between pole and focus. Okay? So P and F, image is formed between, image is formed between pole and focus. And what is the nature of this image? Nature in the sense, characteristics of the image. So first we will compare the size. You see, this is the actual size of the object. But you see the size decreased, image size decreased. Isn't it? So since the image size is decreased, we call it diminished image. Diminished. Okay. And where is the image formed? Is this image formed downward principal axis or upward principal axis? Upward principal axis. So it is erect, upright. Object is this way, then image also this way. Not inverted. Image is upright. Diminished, but upright image is formed. Okay? Erect. Erect image. And what is the last and important characteristics of image? You see, after reflection, rays are diverging. After reflection, if the rays converge, we get real image. But here what is happening? Rays are diverging after reflection. Then what do we get? We get virtual image. So if you extend them backside, they form the image here. This image is formed due to the extension of the reflector light rays, diverging rays of reflection light rays. So this image is virtual image because it is formed behind the mirror, not before the mirror. Okay? So it is a real image. So these are the characteristics of the image when object is placed behind C. So now we are going to discuss this second one. Object is placed at the center of the curvature. Convex mirror, and this is our principal axis. This is real focus and this is real center of the curvature. This is virtual focus and virtual center of the curvature. Right? Now, where we have to place the object? We have to place the object at the center of the curvature. At the center of the curvature. Right? So, this is our object. I am going to draw the object this way. This is my object. So, what are the rules to draw the ray diagram? We have discussed earlier. A ray passes parallel to the principal axis. After reflection, seems to be diverge from the focus. Okay? And the ray passes through, seems to be passes through focus. After reflection, passes parallel to the principal axis. Rays are diverging after reflection. What do? We have to extend them backside. So when we extend them backside, they form the image. We have to extend this ray backside, this ray backside. So both are meeting here. This is the image. So what are the characteristics of the image? And first position we see object is placed between beyond C, even though image is formed between pole and focus. Object is beyond C, image is formed between pole and focus. Object is at C, also image is formed between pole and focus. When object is beyond C, image is diminished. Now also you see image is diminished. Here image is upright. Here also image is upright, erect. Here also image is formed behind the mirror, real. Okay, characteristics are same. Even the position of the object changes, characteristics are same. Okay, so now we are going to understand the remaining positions quickly. Okay, this is the virtual focus and this is virtual center of the curvature, right? Now object is placed between focus and center of the curvature. Tell me rule number 1. A ray passes parallel to the principal axis. After reflection seems to be diverged from the focus. A ray seems to be passes through focus. After reflection passes parallel to the principal axis. So when you extend them, this reflector ray and this reflector ray, when you extend them, you see they will meet here, the image is formed here. Okay, and when object is placed at focus also, let us finish. Object is placed at focus. This is real focus, real center of the curvature, but they are behind the mirror. This is the virtual focus and virtual center of the curvature. So I am keeping the object exactly at focus, at focus. This is object. Okay, right. Rules. A ray passes parallel to the principal axis. After reflection seems to be diverged from the focus. Rule number 2. A ray seems to be passes through focus. After reflection passes parallel to the principal axis. Okay, when we extend them, they are meeting here. So image is formed here. Okay, and you observe in these cases also, what is the position of the image between pole and focus? Between pole and focus. Between pole and focus. That means wherever you place the object in front of the convex mirror, always image form between pole and focus. Between pole and focus. There is no other option. Object, wherever you place the object in front of the convex mirror, image always forms between pole and focus. And what are the characteristics of the image? Diminished, 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 diminished. Comparing to the size of the object, image is always smaller. Image always forms above the principal axis, upward principal axis. So erect. Image always forms behind the mirror due to the diversion of the reflecting light rays. So image is always real. Sorry. Image is virtual. Image is virtual. So previously I have written this is real. No. If the image is formed due to the converging of the light rays, that is real. Diverging of the light rays, that is virtual. So image is formed behind the mirror. So it is virtual image. This is virtual image. This is virtual image. This is also virtual image. Okay. So please note down these ray diagrams. But instead of noting down all these ray diagrams, one common ray diagram we draw, that is this way. You see, so this is pole, this is focus, this is center, real focus, real center of the curvature. We don't mention the virtual focus and virtual center of the curvature because wherever you place the object in front of the convex mirror, here, 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 wherever you place, image always forms between pole and focus. Okay, this is object, this is image, and characteristics is diminished, erect and virtual. So you draw only one diagram. Okay, common diagram. A ray passes parallel to the principal axis. After reflection seems to be passes through focus. A ray seems to be passes through focus. This is seems to be diverged from the focus. This is seems to be passes through focus. a ray seems to be passes through focus. After reflection, passes parallel to the principal axis. When you extend them, these both, they are meeting here. So the image is formed here. So what are the characteristics of this image? This image characters are diminished because comparing to the size of the object, image is smaller. Erect because it is formed above the principal axis. Virtual because this image is formed due to the extrapolation of these diverging light rays after reflection. Image is formed behind the mirror. Okay, so please note down this one ray diagram for understanding. Welcome back, children. So sign convention for spherical mirrors. Okay, so till now we have discussed ray diagrams for both concave mirror and convex mirror. Now we are going to apply the sign convention. Okay, see, we have three rules for sign convention for both spherical mirrors, concave mirror and as well as convex mirror. Okay, to measure object distance, image distance and focal length, also radius of the curvature. These are all distances. See, object distance is denoted by u. The distance between pole and object is called object distance. So this is called u. This is object, this is pole, right? So the distance between pole and object is called object distance or distance of object. The distance between pole and image is called image distance, is denoted by v. And the distance between pole and focus, this is called focal length. These are all distances. While measuring these distances, we have to follow sign convention. So what is the first rule? All the distances should be measured from the pole. If I want to measure the object distance, what is object distance? The distance between pole and object, PO. Okay, I have to measure from the P. I have to start my measurement from the pole. Any distance should be measured from the pole. I have to start from the pole. I have to move from pole to the O, P to the object, pole to the object, not from the object to the pole. Okay, whenever I want to measure the image distance, the distance between pole and image is called image distance. So PI. Whenever we are measuring this distance between pole and image, I have to start my measurement from the pole, not from the I. I have to move from P to I. I should not go from I to P. The distance between pole and focus is called focal length. This is. While measuring this focal length, I have to start my measurement from the pole. I have to move from P to the F, not from F to the P. Okay? So, this is rule number 1. Okay, another rule, second rule. If the distance is measured along the direction of the incident ray, sign to be taken positive. See, this is the incident ray direction. So when object is kept here, from the object, rays coming to incident on this mirror this way. This is the incident ray direction. Here also, when I keep the object, rays incident this way. This is the incident ray direction. If we move along the direction of the incident ray, sign to be taken positive, opposite to the incident ray. That means rays are coming this way. These are the incident rays. If we want to measure along the direction of the incident ray, if we measure opposite to the incident ray, sign to be taken negative. Here, these are the incident ray direction. If we measure from here to here, this is positive, but opposite negative. Okay, opposite to the incident ray, sign to be taken negative. And the third important rule is, okay, before going to discuss the third rule, first we are going to understand the second rule. Okay, so PO, the distance between pole and object is called object distance. Now I want to measure. I have to start, according to first rule, I have to start from P. Then I have to move towards O. So my direction is this is. Okay, I am moving from P to the O. Okay, I am moving from P to the O. But my direction is now opposite to the incident ray. This is incident ray direction. But are we moving in incident ray direction? No. We are moving in opposite direction to the incident ray. So, sign to be taken negative. So, U is negative. image distance. The distance between pole and image is called image distance. Now I want to measure this V. So I have to start from P and I have to go towards I. So P to the I am moving from P to the I this way. This is my direction of measurement. Okay, but my direction of measurement, is it along the direction of the incident ray or opposite to the direction of the incident ray? Opposite. You see, this is opposite. Okay, this is incident ray, but we are moving this way. We are moving opposite to the incident ray. Then sign to be taken negative. Focal length. We are moving from P to the F. We are moving this way. But this direction is opposite to the incident ray. This is incident ray. Are we moving along the incident ray? No. We are moving opposite to the incident ray. Then sign to be taken negative. For concave mirror, sign convention is completely negative. But remember one thing. This image is real image. Right? Image is formed due to the converging phenomenon of the reflected light rays. This is real image. For real image, sign convention is negative. But same convex mirror, when object is placed less than focal length, this forms the image behind the mirror. When object is placed between pole and focus, this forms the image behind the mirror. In that case, we are moving from P to the I. We are moving along the direction of the incident ray. Then we should be taken positive. When we move along the direction of the incident ray, positive. Yes, P to the I am moving. This is my measurement direction. My measurement direction and incident ray direction is same. We are moving along the direction. Then sign to be taken positive. So positive for which image? Virtual image. For virtual image, sign to be taken positive. For real image, sign to be taken negative. This is important. Okay. Coming to convex mirror. Now we have to measure U, the distance between pole and object. The distance between pole and image is called V, and the distance between pole and focus is called focal length. Okay. Right. So this is pole, this is object, this is object distance. Now I want to measure this object distance. According to first rule, I have to start my measurement from pole. My direction is P to the I, this way. P to the O, sir. P to the O, this way. I am moving from P to the O, pole to the object. But my direction is opposite to the incident ray. This is incident ray direction. But I am moving this way, right? It is opposite. Then sign to be taken negative. U is always negative, whether it is mirror or lens, U is always negative, because when object is placed before the mirror or lenses, rays are coming towards lens and mirror, but we are measuring from the mirror to the object. Our direction always opposite to the incident ray during this case. That is why sign to be taken negative. Okay. Then V, the distance between pole and image. This is image. This is called image distance. This is image distance. We have to move from P to the I. Okay. So we are moving, you see, we are moving P to I this way. And this is incident ray direction. Are we moving along the same direction? Yes, we are moving along the same direction. Then sign to be taken positive. The distance between pole and focus is called focal length. This is focal length. So while measuring this focal length, I am moving from P to the F. Why I have to move from P? According to first rule, we have to start from P. So when we are moving from P to the F, this is my direction. Am I moving along the direction? Yes. Along the direction of the incident ray. Then sign to be taken positive. Okay. I hope you understand the sign convention. And height of the image and height of the object, if it is measured upward the principal axis, sign to be taken positive. You see, this object is above the principal axis, upward principal axis. So sign is positive. Object is upward principal axis. So sign is positive. If any object or image below the principal axis, downward the principal axis, then sign to be taken negative. You see, here object is above the principal axis, that is why positive. Here also object is above the principal axis, that is why positive. But here image is downward, below the principal axis, then sign to be taken negative. Here sign to be taken negative. But here the image is above the principal axis, upward principal axis, that is why sign to be taken positive. So height of the image or height of the object, if we measure upward principal axis, sign to be taken positive, Downward principal axis sign to be taken negative. So these are the three sign conventions, very, very important, which is related to the spherical mirrors, both concave mirror and convex mirror. And for concave mirror, you have to focus mainly on this image distance. While we are measuring the image distance, sign is negative if the image is real. That means if the image is formed before the mirror. When image is formed behind the mirror, for virtual image, sign to be taken positive. This is you have to focus. Okay, so please learn sign convention and write down these sign conventions in your notebook.